This is your first video in a series about the 5 different reaction types. In the end, the learning target about those 5 reaction types is the one on the screen. You need to be able to identify which of the 5 reaction types it is simply by the reactants that are given. So that's what I want you guys to focus on as I go through each reaction type. Okay? This video will just be on the first reaction type, which is a synthesis reaction. So a synthesis reaction is also called a combination reaction, and I'll pretty much use those interchangeably. I tend to favor synthesis, but you'll see both. And the deal with those reactions is that you take two simple substances, which are generally just single elements, and then they come together. Okay? They combine, they synthesize, and when two elements come together to form a chemical change, they're going to become a compound. So if you look at the general form of the equation for a synthesis reaction, you have some simple substance A and some simple substance B reacting with one another to make AB, which is a compound. Two examples of this reaction type is a hydrogen gas with oxygen gas coming together to make water, or carbon coming together with oxygen to make carbon dioxide. Okay, these are two examples where two single substances are coming together to make a compound. So off that learning target, the way you'll be able to identify that your reactants are going to synthesize is that the reactants will be two single simple substances. Okay. Diatomics will count as single substances. So if you look at that water example again, hydrogen, since by itself is always H2, that still counts as just one single substance rather than like a molecule. Over time of the reaction types, some of them your target will be to be able to determine whether the reaction will happen even or not. And for synthesis reactions, we can just assume that if you're given two simple single substances, they will combine into a compound every time. Okay, you don't have to think harder than that. Of course, there are always special exceptions and special cases when we're talking about chemistry. So at the bottom in that box, there are two cases where we're going through a synthesis reaction, but it doesn't look as simple as two simple substances. And one of those special cases is when you have a metal oxide. So that means you have a metal with an oxygen attached to it. And the chemical formula there will be whatever formula you need to generate based on the charges. And when that metal oxide reacts with water, what happens is the synthesis is that you add basically another component onto, you add that water onto the metal oxide. So you're making a hydroxide group there. Okay, you're adding the hydrogen part to the O, and then determine the chemical formula of that metal hydroxide is again based on charge. So for the case of calcium, you had two hydroxide groups because calcium is a charge of 2. The other special case is almost the same as the other one. This time it's a non-metal oxide. Okay, so you have a non-metal bonded with your oxygen, and in that case I'd have to give you the chemical formula because you can't predict what the subscripts would be, since this is a covalently bonded compound. And when your metal oxide reacts with water, what you make is an acid. Okay, the hydrogen and oxygen adds to it to make some form of acid. Now, in terms of predicting the effect it will have on oxygen, you can see here for that sulfur trioxide that one oxygen was added to make sulfate, and then you add as many hydrogens as you needed to make the acid balanced. And that's a general thing that we see. I'll show you some more examples, but usually we see that an oxygen is added, and then as many hydrogens that need to be are added to make the acid neutral. Okay. So that is a synthesis reaction. To show you a pictorial representation of what that looks like. It's kind of silly. I'll do these every time because I think they're funny. You have a really emaciated bird with a worm, two simple substances. When they are synthesized or combined, you end up with a really fat bird. A more chemical pictorial representation of a synthesis reaction, if you look here, on the left-hand side you have two simple substances, and on the right when they come together you can see how they're interwoven to make an ionic compound. Okay? And in terms of those pictures, you can see that there was like a color change and the substance looks different. So obviously there is a chemical reaction when this happens. Our goal with this tomorrow is to be able to actually predict products in terms of what will happen as these things come together. But for now, you just have to have a general sense of what a synthesis reaction is. Okay? Have a nice night.